Okay, so I suppose we'll get started. So I welcome you all to this problem solving and live interaction session for this course on engineering mechanics that is being offered by Professor K. Ramesh in the SWAYAM portal. So before I begin with the introduction, I just want to share my screen and show the discussion forum. I would encourage you to. So this is the engineering mechanics course. Uh, Yeah, okay. So this is the engineering mechanics course page. As you can see on the left side, there is week one, week two, which is live right now. And then we have the video downloads, text transcripts, and then live engineering mechanics sessions. So if we, the, this session that we are going to have, it will be recorded and I will be uploading those videos to a link which you can access from here. This live engineering mechanics, if you click, it will take you to a drive or a YouTube channel where you will be able to see this video after the recording. I'll possibly upload it at least I'll try to upload it the same day as the session is conducted, so that you can have it at your disposal. And the another thing I wanted to emphasize was this: if you go to this ask a question, if you click and open it in a new, or rather, I'll open it in the same tab. This ask a question is essentially a discussion forum where doubts related to this course you can raise. And I would encourage you to, if you're interested, you please join this group so that when we answer someone, you also get a mail about the response, and it will be towards a better learning experience. If there are some queries which are more elaborate to be answered in the forum, we would also suggest you to attend this live session where you can ask, and the other way around. If there are any remnant doubts after this live session, you can always post it in the forum, and we'll try to get back to you as soon as possible. So this is something I just wanted to clarify before we get started. So I'll just stop sharing the screen now, and I'll share the screen from here. Okay, so I suppose that my screen is visible. Okay, so I welcome you to this problem solving and live interaction session for week one. My name is Ganesh Ramaswamy. I'm a PhD scholar in the Department of Applied Mechanics, working under the guidance of Professor K. Ramesh and co-guide of Professor U. Saravanan from the Civil Engineering Department. And I'll just brief you through what this session is. So essentially, I'll be solving questions that will pertain to the contents of each and every week as we go about. There are 12 weeks to this course. So we will start with week one now. And I'll try to solve questions, and whatever doubts that are there based on those questions, you please feel free to raise them. You can unmute and ask, and if it becomes too chaotic because of the number of people that are attending, you can always type it in the chat box and we'll try to take it up as we go about during this session. So I encourage you to make the most out of it. I'll try my best to answer each and every questions that is being posed. If I'm unable to currently right away answer it, I will keep a note of it and I'll try to address it in the next session. So to answer this, this session will be conducted weekly once on Fridays, 6 to 8, and it will be the same Google Meet link as you have joined with right now, and it will be throughout the duration of this course. So before we begin and look at some of the questions, if there are any questions that you have, I would like I'd be more than happy to take them now. I take it that this is clear, the and my voice is also clear, I hope. So okay, then let us get started. So let us look at the first question. But before we look at the first question, it is important, and each and every week you will be finding the instructions to all the assignments, which are more or less common for every week. So which we need to keep in mind, because given the sheer volume of the number of courses that are being run on the SWAYAM portal, it is not possible for each and every course to be graded manually. Hence, we go for computerized grading, which has its merits, but there are some limitations that we need to, limitations in the sense there are some constraints that we need to respect, in the sense that if there are your answers, numerical answers are beyond that range, it might be graded as incorrect, even though you might have understood the concept clearly. So it is very essential that while doing the calculations, you please abide by the instructions that are given in on the top of each and every assignment sheet. And mostly G value when we'll take it to be 9.81 instead of 10. And mostly all the questions will have its units mentioned there. So please make sure that you answer the questions in the units that have been asked in the question. And other than that, the things are pretty straightforward. So we'll take the questions as we the go along solving the problems. Okay, so let us look at the first problem. Which of the following representations, one or more, follow the laws of vector addition to give A plus B equaling R? So we have four options here. So if we take case number one, if I take case number one here, I have a vector like that, which is A, and I have a vector like that. Now we know that when there are two vectors to be added, essentially what we do is we place one, the tail of one to the tip of the other, and then connect the rest to get the resultant. If this is A and this is B, this gives C such that C is a vector sum of A and B. This is pretty straightforward. I suppose almost nearly all of you would be familiar with this, but it is good to start with some fundamentals and then build upon them so that we don't get stuck midway somewhere. So with this background of understanding, if we look at the options that we have here, I'll just remove this option that we have here. So we have A like that, and then B takes it down, and then we connect the the tail to the tip of the vector, and we get resultant. So this surely follows the law of vector addition. Similarly, if we were to go here, in case B, we have A and then B, which is already connected to the tip of A, and we have the resultant connecting this. So this also follows. Now coming to C, if we see that A, we have a horizontal force A and then a vertical force. Force, I don't want to specify this as force. Let this be any generalized vector, be it displacement or whatever, come what may. Now if we take this to be the B vector, essentially our rule of vector addition says that once I have A like that and B like that, my resultant should be drawn from the tip of A to the from the tail of A to the tip of B. This is my resultant. But if we see here, the resultant has been put in the opposite direction. So this does not follow the law of vector addition. Hence, this is not one of the correct answers. D, if we look at, we see A here, and then B, we have a vector like that. The only difference here is that the tail of both the vectors are put together. So we can always take it here and then put it from tail to tip and then connect it, and we will be able to see that we are getting the resultant R vector. Please use Hindi and English. Okay, I'll try to use Hindi and English. Let me make it clear that I'm familiar in three languages: English, Hindi, and Tamil. Uh, Tamil and Hindi, I might not know the technical terms specifically, so I might still be using the words like force. So I hope you can bear with that. And I would generally conduct it in English, but if there is a need and if there is a doubt which needs to be answered, and if language be the barrier for the understanding, I will definitely resort to the other languages out of the ones I know. I hope you can bear with that. So we can see that option D definitely follows. So the answer to this is 1, 2, and 4. 3 does not follow the law of vector addition. I hope that this is clear. If there are any questions, please feel free to ask anytime. And another aspect to this is that once the session is being recorded and the file in which I'm solving these questions, these also would be shared along with that live session. When I upload that, I will also be uploading the solved questions here. The dictum is that I'm not supposed to solve the questions from the current assignment that is live right now. So that is something I will not be doing. If you have questions regarding those, you can always approach the forum and we'll try to answer that. But more or less, if you see the conceptually, we are trying to cover questions which are essentially the same. Only the concept which has been applied is same and the appearance varies. So if you are able to get the concept from here, you'll be able to easily extrapolate that to apply to the current assignment problem. So I hope that that is clear. Okay, so if there are any questions, please do raise. Otherwise, I'll move on to the next question. Yes, please. Yes, Mr. Nishant. थोड़ा सा आप वॉल्यूम थोड़ा सा कम करके बोल सकते हैं क्या? मैं एकदम ढंग से सुन नहीं पाया। हाँ, ए सी सी आपको राइट लगा था, थर्ड ऑप्शन आपको राइट लगा था। हाँ, वो इसलिए है क्योंकि देखिए अगर आपका एक फोर्स ऐसे है, ठीक है, और दूसरा फोर्स कहीं स्पेस पे है, तो इसका एडिशन का रूल ये होता है कि एक के टिप को आपको दूसरे के टेल पे लगाना है। आपने ये जब लगा दिया है, देन यू हैव टू फिर आपको कनेक्ट करना है इसका टेल इसके हेड से। टेल टू हेड ही हमेशा कनेक्ट होगा, ऐसे नहीं कि आप हेड टू फिर टेल करें। अगर वो वेक्टर एडिशन वो ये फॉलो नहीं करेगा एसेंशियली। सो दिस हाँ जी बताइए। हाँ, ये फॉलो नहीं कर रहा है। अगर मान लीजिए कि आर आपका दूसरे डायरेक्शन में होता, आर का हेड इस तरफ होता, तो वो फॉलो करता। बस यही फर्क था, है ना? ओके, या ओके, सो आई टेक इट दैट दैट इज क्लियर. So let me move on to the next question. And there will be some aspects to the assignment that I will try to highlight as and when it appears. So if you see a square button here, it implies that the question is multi-select. It could, not necessarily, it would, but it could have more than one answers. So you should select them appropriately. And the grading scheme, I think that is pretty clear that if there are three answers to a question which has four options, and if you select any one or two of the correct answers, you will be partially graded. But along with them, if you select one of the wrong answers, you lose the entire marks to that question. This is to discourage guessing. So I suppose you can bear with it. It's a standard procedure. I just wanted to brief you about this in case you are attempting the assignments and I don't want you to be up for a surprise. Okay. So let us look at this question. Which of the following statements are correct? Is what is asked. So the first statement is the magnitude of a vector can be a positive or a negative quantity. So a vector is characterized by two things, magnitude and a direction associated with it. So essentially the difference between this vector and its negative is only in the unit vectors that make it up. It does not have anything to do with its magnitude essentially. Magnitude being the length of the vector is still the same. It is not exactly appearing to be the mirror image of that. So I would rather draw this again. Please, yeah, okay. I'll do that, please. Hold on. Let me explain it in English first. So we have a vector like this. This has a magnitude and a direction associated with it. So if we were to place it in space, if we were to place it in space, and let us say this is the x direction, this is the y direction, and I have this pink colored vector. Now this is some angle that it makes with the x-axis. So the moment we have an angle, we have that direction that is associated with that vector. What else is needed to characterize this vector? Its length. Once we know the length and its direction, we'll be exactly able to know everything about that vector. So that length is what is characterized by its magnitude, and the direction is what is defined by theta. So yeah, so in case we consider the same example, but with a negative force, essentially what happens is our theta is what has changed. The magnitude still remains the same. So the magnitude of any vector which characterizes its length is invariably a non-negative quantity. So this is not correct. क्योंकि एक वेक्टर है तो उसका लेंथ जो है उसका मैग्नीट्यूड उसका लेंथ को रिप्रेजेंट करता है. उसके अलावा उसका डायरेक्शन कोसाइन जो है किसी भी बेसिस के हिसाब से वो उसके डायरेक्शन को कैरेक्टराइज करेगा. फोर्स के लिए मैग्नीट्यूड और डायरेक्शन ये दो ही चाहिए होता है. तो मैग्नीट्यूड कभी नेगेटिव नहीं हो सकता है. अगर हम देखें इस एग्जांपल को जिसमें हम देख पा रहे हैं कि एक दूसरे का मिरर इमेज है, तो उस जगह पे उसका डायरेक्शन चेंज हुआ है. डायरेक्शन थीटा पहले था और दूसरे केस में थीटा प्लस 180 हो गया. बस वही फर्क था. तो मैग्नीट्यूड उसका चेंज नहीं हुआ. मैग्नीट्यूड इज स्टिल द सेम. And I hope you'll be able to bear with me because certain people have requested that I also explain it in Hindi at certain times. So I'll try my best to switch between both. And if there are any requests for Tamil, I can do that also because these are the only three languages I know. So I request you to bear with me in that respect. Okay. Then coming to the second question, second part. Vector is a quantity that only has a magnitude associated with it. We just discussed that it is not so. A scalar is a quantity which has only a magnitude associated with it. A vector has a magnitude and a direction associated with it. And a tensor, strictly speaking, a second order tensor like a stress, it has one magnitude and two directions associated with it. It is not sufficient that we mention only a force, but we also have to mention the plane. We also have to characterize the plane on which it is acting. So that is what a second order tensor is, but that is out of the purview of this current discussion. I just wanted to just briefly mention that. So this is not correct because vector has a magnitude as well as a direction associated with it. The third option says if two force vectors are collinear, the resultant of those forces would also be along the same line. So yeah, collinear essentially means that it is along the same line. So let us say that I have a force here and then I have another force which is somewhat of a different magnitude. Now if I were to add these up, the resultant of these, what is the vector rule that I have to follow? That I have to place one's tail on another's tip and essentially join this tip to that head, that tail to that head. So the green vector, if we see, I will just draw it above this. You just consider that it is on top of this. I'm just drawing this to make it clear. So this would be the resultant of that vector if this is A. If this is A and this is B, so we will have this vector as C such that C is the vector sum of A plus B. So we are able to see that it will be in the same line. If we were to reverse one of them, C would just become shortened. That is all the difference there is. So yes, this is Correct. It holds. A position vector is a vector that locates one point in space relative to another point. Yes. So essentially what we do while discussing, I'll just add one page here. Position vector is essentially useful in dynamics because we, even in statics, for calculating moment, essentially if we have a body and we apply a force on the body and we are trying to calculate its moment about some point O. Now this is where the force is applied. So essentially I have to find out this vector. If I call this point A, then this vector is RA with respect to O. Now RA with respect to O, this A is where force is applied. O is a point with respect to which moment is calculated. Now this I'm just trying to explain with an example of a force and a moment, this thing. So it will apply same to other vectors like displacement, accelerations and so on. I hope that that is clear. So what we essentially do is when we say if we are to calculate R A with respect to O, what is the first step we do is we imagine in the Cartesian coordinate system, we imagine XY axis. We are talking about planar conditions right now, XY plane. When we go to 3D kinematics, we will explore the third dimensions also. But essentially, the principle still remains the same. Now, let me have these as dotted and let me color this in some other color. Okay. So first thing we do when we have to calculate this RA with respect to O is we will take a coordinate system. We know that we have to calculate RA with respect to O. So we have to fix that coordinate system at O, the origin of that coordinate system at O. We know that the origin of this coordinate system, we have to shift it to O. So we have put that at O, you can clearly see. Now the position of A with respect to O, with O as the origin, we can easily calculate once we know this distance. How? This distance, let us say its length by some geometric condition, we know its length, whatever that is. Let me not draw it here, let me draw it here. Let us say this is some M and I know this makes an angle theta. So my R A with respect to O would be M cos theta. What is the unit vector in the x direction? I cap plus M sin theta j cap. This is how we will write A with respect to O. Now if we were to do the same thing of R O with respect to A, let us say R of O with respect to A. This is nothing but the negative of R A with respect to O. So therefore R O with respect to A essentially means that this coordinate system, the green coordinate system which we have fixed to A, fixed to O, we have to fix it to A with A as the origin and then look back at O. That will essentially be the negative of that vector. So it will be minus M cos theta I cap plus, sorry, minus M sin theta j cap. This is all there is to know about position vectors. So essentially, if we look at the last option, a position vector is a vector that locates one point in space relative to another point. We have discussed a case of a plane, which is a special 2D space. It can be generalized to 3D space also. So I hope that it is clear. So yes, this is correct. So if there are any questions on this, please feel free to ask. Yes, please. फोर्थ स्टेटमेंट क्यों सही है आप पूछ रहे हैं? हाँ, तो जैसे पोजीशन वेक्टर क्या होता है? पोजीशन वेक्टर होता है जैसे एक पॉइंट को दूसरे पॉइंट के रेस्पेक्ट पे डिफाइन करना ना। जैसे आप ओ पे हैं और आपको ए का वेक्टर ढूंढना है, तो आप सबसे पहले ओ पे आप एक कोऑर्डिनेट सिस्टम लगाएंगे एक्स वाई का। अगर प्लेन है तो 3D है तो एक्स वाई जी लगाएंगे, और दूसरे पॉइंट को उस पॉइंट के रेस्पेक्ट पे आप वेक्टर के इन द फॉर्म ऑफ वेक्टर आप एक्सप्रेस कर रहे हैं, बस वही कर रहे हैं। तो ये क्या कर रहा है एसेंशियली, ये पूरा जो प्रोसेस है ये पॉइंट ए को ओ के रेस्पेक्ट में बता रहा है आपको। तो लास्ट ऑप्शन क्या बोल रहा है कि पोजीशन वेक्टर वो वेक्टर होता है जो एक पॉइंट इन स्पेस को दूसरे पॉइंट के रिलेटिवली बताता है ना? या ओके, या ओके, सो आई टेक इट दैट दिस इज क्लियर. Okay, so let us move on to the next question. Which of the following is our sliding vectors? Force vector, position vector, and moment vector. So essentially we need to understand about vectors. So we will have free vector, we will have fixed vectors, and we will have sliding vectors. Now let us say I have a system. Sliding, yeah, I'll come to that, I'll explain that. Let us say I have a system and I apply this with two forces. Okay, let this be force P and let this also be force P, and let us say that this distance is D. Okay, and this is the body that this mushroom colored body is where I'm trying to apply this force. So what will be the net effect of this force? Let us say that I calculate the moment about this point. Let me call this O, and let me have a coordinate system like that. X, Y, I'll put this in green and I put it small. So let me fix an xy coordinate to that point now. I have fixed an xy coordinate to that point. Let me fix it properly. Yeah. So now I'll calculate moment about O. Moment is given by R cross F. It's a cross product. So what is R? R is, let me call this point as some A. Okay. So moment at O is R A with respect to O. Force and moment vector are sliding vectors. Correct answer is option A. Okay. So one person has given the correct answer. So we'll discuss anyway why that is. Crossed with force. Force is P vector. Now let me express this in component form. This will be D I cap because x के डायरेक्शन में एक यूनिट वेक्टर है I और वो डिस्टेंस है D. तो D I cap क्रॉस्ड विथ माइनस P J cap क्योंकि फोर्स y के डायरेक्शन में लग रहा है, नेगेटिव y के डायरेक्शन में लग रहा है। तो इसमें इसका मैग्नीट्यूड ऑफ द फोर्स इज P and the direction cosine is 270 degrees which is minus j. तो इससे एक मोमेंट निकल के आएगा PD. Moment will be minus PD k cap. Okay, now this moment, it's a couple that is getting formed, and this, if I put that couple, let us say I represent the same system. एक मिनट. Now what I'll do is I'll replace this with that coupled system. ये फिर से ही बना लेता हूँ 1 मिनट. So what is the total force? Total force acting is 0 because I have P here. I have P like that. I have one P like that and the other P is acting like that. So how will I add them vector? How will I do the vector addition? I will take this. I will put its tip onto the other's tail and I essentially come back to the same point. What does that mean? That the net force is 0. There is no force acting on the system. Net force acting on the system. So I hope that that is clear. Net force equal to 0. Net moment is PD. About this point, there is a couple like this. It so happens that when there are two equal and opposite forces which are placed a distance d apart, needn't be d, call it any variable apart, it will create a couple and that couple is a free vector. Meaning, I can move this around to any point in this body and it will give me the same external effects. It will still rotate and give me the same external effects. This is what is meant by a free vector. This is a free vector. Okay. Next, if we look at fixed vector, essentially position vector is a fixed vector in space. Because if we look at this example, if we have point O and point A, right now we are, I want this full session link, where can I get it? Yeah, I had discussed it initially. If you go to the Swayam portal, on the left side bottom, there will be live session recordings. First, this is the first session. So once this session is completed, I'll upload it somewhere and I'll provide the link over there. It will be made available to you in due course of time by the SWAYAM team. So that along with the video that is being currently recorded, I'll also be sharing the file on which I'm writing so that it becomes clear. And if there are any doubts based on that, you are more than welcome to ask it in the discussion forum or bring it up in the next session that we have. And this session will be going on throughout the duration of this course every Friday, 6 to 8, 6 p.m. to 8 p.m. So I hope that that is clear. Yeah, okay. Yeah, so we were discussing about fixed vectors. So right now we are dealing with a course that idealizes bodies as rigid. We have not gone to idealizing them as deformable. So what does rigid mean? That under the action of loads, the distance between 2 points, any 2 points on any object, it doesn't change. So that is what the definition of a rigid body is. So essentially, when I say R of A with respect to O, point O is fixed, point A is fixed. The fixed meaning I needn't say that this is specifically point O. I could take any point and label it as O. But once I have labeled it and I have labeled A with respect to it, nothing else changes. I have to be consistent with that. In such a case, the position vector becomes a fixed vector. So that is what a fixed vector is. Now coming to a sliding vector. For understanding sliding vector, we must understand something called the principle of transmissibility. So principle of transmissibility of a force. What this says, let us say I have an object like that. And yeah, I'll repeat this in Hindi. I'll try to repeat this in Hindi. First, let me cover it in English. Let us say that I have an object like that and I apply a force here. What do we anticipate this to have a translation? And rotate. Call it its CG is here. It will translate as well as rotate. Now the principle of transmissibility states that if I have a line along, if I have a line like that, let me make this line dotted. Let me color it something else. So the blue dotted line is the line of action of that force. Let me move it a little bit and get a copy of this. I'll keep that force for now. This is the line of action of that force. I hope this is clear. एक बॉडी है, रिजिड बॉडी है, जिसपे हमने एक जगह पे फोर्स लगाया हुआ है. ठीक है, अब एक लाइन हम ड्रॉ कर रहे हैं जो उसके लाइन ऑफ एक्शन के थ्रू जा रहा है. उस फोर्स का एक्सटेंशन है वो. इट्स एन इमेजिनरी लाइन. What is the difference between sliding vector? Yeah, let me first try to explain what sliding vector is, then we'll come to the difference. That is what I'm trying to do. To understand what sliding vector is, we need to understand what principle of transmissibility states. So there is a rigid body. I have a force applied onto that rigid body. I consider one imaginary line passing through the line of action of that force. उस फोर्स के लाइन ऑफ एक्शन के थ्रू एक इमेजिनरी लाइन हमने ड्रॉ किया. अब इसका मैं कॉपी बनाता हूँ एक. ठीक है, इसको मैंने हटाया, ये मैंने डिलीट कर दिया, और ये वही लाइन ऑफ एक्शन है, सेम लाइन ऑफ एक्शन. अगर मैं उस फोर्स को उस लाइन ऑफ एक्शन के अलोंग कहीं भी मैं रखता हूं, जैसे यहाँ पे मैंने टिप पे रखा हुआ था, यहाँ पे मैंने थोड़ा सा हटा दिया इसको. अब मान लेते हैं देयर इज अ थर्ड केस वेयर आई विल जस्ट अ मोमेंट. This is that line of action, okay, and now I place the force here instead of that place. All these three will essentially lead to the same external effects. Lead to the same external effects. This is what principle of transmissibility states. कि एक force है, if there is a force, and if you move it along its line of action, if there is a force applied to a rigid body, and if you move that force along its line of action, the external effect on that body remains the same. What is the external effect in this case? It will translate and rotate. अगर आप उस फोर्स को लगाते तो ये होगा क्या? ये ऐसे जाएगा और घूमेगा ऐसे. So that is the external effect. This is what principle of transmissibility states. Now this can beg a question. Moments will be different. Moments will not be different. That is the entire thing. Let us say this is the CG of that body. Okay. It's a good question you have brought up. Let me try to answer it convincingly. ठीक है, ऐसे दो फोर्स है. अब इसमें आप, मैं अभी के लिए ये लाइन ऑफ एक्शन अच्छा रहने देते हैं. Let me, we know that moment is r cross f. Okay, moment is also a vector and force is also a vector. We know that moment is r cross f. In the first case, how will I calculate moment about g? From g to tip of the force. This will be my r. Let my force be f. Let the force applied be f vector in all the cases. Here also I will have f. Here also I will have f. In the first case, my r is that. In the second case, this is my r. In the third case, this is my r. It appears that r keeps on changing because I am trying to move the force along its line of action. It is very important that we note this. It is along the line of action, the movement. It is not away from it. Essentially, there is a line of action of a force and we are moving only along that line of action. As you can see, it was here, then it went there, and in case 3 it has gone up to the top of the body. In these three cases, if you calculate moment, it will be the same. This is a very, it could be counterintuitive for someone, but it is essential to understand this, that the moments will be same. Is it clear? Since the moment is same and the force is same, so the external effect brought about by that is same. This is what principle of transmissibility states. Now this can beg another question. What if why are we so focused about external effects? What about the internal effects? Internal effects meaning, let us say I have a body like that, okay, and I'm pushing it, and I take the same body. This example is discussed in the lecture also. Let us say using the principle of transmissibility, I move the force along its line of action and I apply it here. एक में उसको धक्का दे रहे हैं, दूसरे में उसको खींच रहे हैं आगे से, है ना? बट ये हमको ध्यान रखना है कि दोनों फोर्स के लाइन ऑफ एक्शन पर ही हमने मूवमेंट दिया है. यस मिस्टर वरुण कुमार. यस. ओके. या ओके. सो all right. I thought it's a technical question. Anyway, so yeah, yes, please. Same, yes. हाँ. हाँ, जैसे जैसे मान लीजिए मैंने यहाँ लगा दिया इसके बजाय, आप ये पूछ रहे हैं ना, है ना? ये अलग केस है, इस पे हम आएंगे. पहले क्योंकि प्रिंसिपल ऑफ ट्रांसमिसिबिलिटी मैं स्लाइडिंग वेक्टर समझाने की कोशिश कर रहा था ना, इस वजह से मैं अभी फोकस कर रहा हूँ मूवमेंट अलोंग द लाइन ऑफ एक्शन. वी विल डेफिनेटली कम टू दिस कि लाइन ऑफ एक्शन के अलोंग जब नहीं होता है तो क्या होता है. विल कम टू दिस. ओके. या. सो दिस वाज हियर. आई हैव मूव्ड इट to the front. Essentially, both should translate to the left. So the external effect still remains the same. But if you see the internal effect, अगर आपको, because you might not be familiar with deformable bodies, the stress will be more here, and in the second case, stress will be more over there. So the internal effects are not the same. Pushing a body and pulling the body, externally it might be the same, but internally it is not the same. That is why principle of transmissibility only applies to rigid bodies. Exactly. But they are rigid bodies, so it doesn't matter. Exactly. So that point, I suppose it has been conveyed successfully, or you would have perhaps gauged it by your own, on your own. So this is what a sliding vector. So force essentially is not changing its. Yeah, Ankur, Mr. Ankur Bhardwaj, I will answer your question, so you can unraise your hand so that. Yeah. Okay. So force essentially is a sliding vector because when we slide the force along its line of action, it does not cause any external change, external effect change. That is what a sliding vector is. Now we know that moment is r cross f. This is a fixed vector, and we have force as a sliding vector. So what should moment be? R is fixed, and force F is sliding. So essentially moment also becomes a sliding vector. Yeah. So moment also becomes a sliding vector. So I hope that that is clear. Sliding vector. Yeah, I saw some gate exam, some question. I'll come to that one in a minute. So force is a sliding vector, position vector is a fixed vector, moment is a sliding vector. So 1 and 3. So whosoever had answered 1 and 3, it is correct. So I hope I explained it clearly. Gate exam and swayam ரெண்டுக்கும் என்ன புக் யூஸ் பண்ணினா படிக்கலாம் இன்ஜினியரிங் மெக்கானிக்ஸ். இன்ஜினியரிங் மெக்கானிக்ஸ்க்கு நீங்க மெயினா கோர்ஸ் கோர்ஸ் அசைன்மெண்ட் சால்வ் பண்ணாலே பண்ண முடியும். பட் அதர் தென் தட் இன்ஜினியரிங் கேட்டுக்கு படிக்கிறதுக்கு நீங்க கேட்டோட ப்ரீவியஸ் இயர் கொஷின்ஸ் எடுத்து படிச்சாலே போதும். அதுல ஏதாவது டவுட் இருந்ததுன்னா நீங்க இந்த ஃபோரம்ல கேட்கலாம், which we'll try to answer. Okay, because doing it as an academic exercise as a course and preparing for gate are two different things. So if you have all the time in the world, then you can focus on books. Other than that, you may as well go with the material that is available from the previous years. Solve them, get the concepts clear. Once you get the concepts clear, you can apply that to anything. So for practice, you can find problems from Miriam Engineering Mechanics. Okay. But it is not exhaustive. Let me be very clear that it is not exhaustive in the sense you don't depend on it fully. Depend on your understanding of the concepts so that you can, solve any type of problem. Yes, please. Somebody had raised their hand. Please go ahead and ask. Okay. 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 I'll try to explain here. You can refer the lecture. It is said in the lecture. You watch lecture number 2 or 3. It will be discussed there. Professor will be discussing it there. Okay. Main lecture notes transcripts would be available on the Swayam portal on the left bottom. Text transcripts, it will say. No, that we don't have access to. That only professor has access to. Okay. But those slide screenshots along with the text explanation is what is provided in the transcript. So the transcript should serve your purpose well. There is absolutely no problem about it. Yeah. Yeah. So what I was saying is if there is a body that is applied with a force being a sliding vector, why if I apply a force and it slides, essentially its dependence get carried over to the moment vector, right? If one variable, simply speaking, if one variable is fixed and the other has a variation, what will you call m to be having? Will it have variation or not? That is all the principle is. M, yes, m won't vary. Why m won't vary is because this distance, what is m? M is essentially a cross product. So the cross product between these two will essentially involve this perpendicular distance only. And that perpendicular distance always remains the same. This is why moment will come out to be the same. You can calculate it and see for 2, 3 cases. Okay, yeah, all right. Okay, so I take it that this is clear. I'll just remove this. Let us move to this question. The resultant force on container C, there is a container C, from the tensions in the cables due to the tugboats. These are tugboats, essentially they are trying to pull it or something. A and B is known to be along the x-axis. So they have given x-axis like that, y-axis like that. One thing that we need to keep in mind throughout the duration of this course and essentially throughout mechanics study is that we follow the right-handed coordinate system. What that means is if we have x like that and y like that, so z will invariably be pointing out of the plane of the paper or out of the plane of the screen as we see it. So z would be like that because of the right hand rule. So this is how we have to follow cross products also. Please don't forget this. I'll just keep it here. Okay. So here x is to the right, y is to the y is pointing upwards. So can anyone tell me where positive z will be? Will it be out of the plane of the paper or into the plane of the paper? Yeah, no, essentially it will be in because if we see the cross product, x cross y goes into the plane of the paper. X cross y. See, in this problem, positive x is given to the left side. If you see this problem, the positive x is defined to be on the left side, right? So that is why it differs. Otherwise, what you are saying conventionally is correct. And y is to the top, so x cross y goes into the plane of the paper. Okay. Yeah. Okay. So they have said that the resultant force on container C, let me take container C and put it here. I have at this point, I have two forces that are being applied. One is like that, and some another force is applied like that. This is FB. This is an unknown force B. This is X direction. And this is given to be some theta. This is given to be 35 degrees. And this force is given to be 50 newtons. I suppose it is in Newton. Okay. Yeah, it is in Newton. Right. So this is 50 Newton, which is FA. Let me color this in something else. Okay, the axis is colored in pink. And I have Y like that. So this is essentially the free body diagram of that container C. Now there are certain constraints given. Let us look at them. Let me draw the arrowhead correctly once. So I hope that this is clear. Now what they are asking is what should be the value of theta for force FB to be minimum and the resultant to be along the x-axis. So this is a rigid body. So we are only concerned about the force that not the extra. We are not concerned about the internal effects that are happening. Let us say that I redraw the force F like that. I'll take it to the next page. Wait a minute. Let me put it here and erase these things. This is my x-axis. And then I have a force applied like that, which is known to be 50 newtons. And this angle is given to be 35 degrees. And then I have another force at some theta. It is applied. Now, if I were to find out the resultant of these two forces, what is it that I have to do? I have to take this force of unknown magnitude and apply it like that. Okay. And then connect this like this. So that will be my resultant vector. Now the question says that that resultant has to be along the x-axis. So what this means is this force, let me remove this. The force here, whatever is applied, should be such that my resultant essentially comes to the x-axis. So if I extend my x-axis like this, let us say that I extend my x-axis like that. Okay. Let us say this is my x-axis. This is x. Now 50 Newton is applied. Now next is to apply FB. This FB that is applied. This FB that is applied. Let me add it to this vector. Let me say this is the force FB. This leads to my resultant come like that. And it is along the x-axis. So it is not difficult for us to think that there could be infinitely many combinations of f and theta that could take the resultant to x direction. This also will take the resultant in the x direction. This also will make the resultant in the x direction. So anywhere I move along this line, my resultant will be in the x direction. Now the question says, the constraint is, first constraint we have respected. It says the resultant should be along the x direction. What is the second constraint given in the question? FB should be minimum. When is FB minimum? We can see pictorially, we can see that FB will be minimum when this is perpendicular to this. This is the least length that FB can have. I hope this is clear. When this becomes perpendicular, this is actually FB. Okay, I'm not putting the arrow head. So let me put that now. So this, when this becomes perpendicular, that is when it will be the shortest. So FB essentially will be minimum only when it is perpendicular. Now, if I put my coordinate system here, x and y, this was theta. If we remember correctly, this force, any force that is applied, and I have this was essentially theta given in the question here. So they are asking what theta will meet these two constraints. I know that when I select this force and make it perpendicular to the x-axis, that is when FB becomes minimum and the resultant is along the x-axis. That is when I have respected both the constraints, rather satisfied both the constraints. In such a case, what is my theta? Theta is this angle. So theta becomes 90 degree for this to be correct. Is it clear? Yes. Yeah. 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 It will. Yes, that will cancel out the resultant, which is what I'm coming to. It's a good point that you have asked. Which book is good for engineering statics and dynamics? Mr. Varun Kumar, I would request you to please watch lecture number 3. Mr. Ankur, I'll come to your question. 1 minute. Yeah. Varun Kumar, you can watch lecture number 2 or 3, where Professor has discussed the books that you can refer for statics and dynamics. Essentially, it is Miriam. Apart from Miriam, he has suggested some other books also to have a good comprehensive hold of the subject. For GATE exam, you may as well go with the first you go with the previous year questions. You get your doubts clarified, then you can think about referring books. Because you also have to weigh in against the weightage for which it is asked. So you can go with Miriam. Other books are discussed in the lecture. Yeah. Yeah, so what he was asking, Mr. Ankur was asking, I'll just answer 1 minute. Now we have clearly established that theta needs to be 90 degree for it to hold, for this constraint to hold. In this case, what is the minimum magnitude of FB is what is asked. Now let us redraw this scenario again. I'll not draw the container. I just have this force. This is at 30 degrees or 35 degrees or whatever, 30 degrees. Then let me draw that force in red. Okay. This green force can be resolved into two components, which is this and this. The horizontal component, this will be 50 cos 35 degrees. And this will be 50 sine 35 degrees. I hope that is clear. 50 sine 35 degrees, I can move this component to this place. This is what makes this force up, right? Delete this. So essentially what I have done is I have simply resolved that 50 Newton force into x and y components. I hope that is clear. Now the next is it has to be acted upon by one force which brings its resultant to the x-axis. So what will that force be? That force will exactly be equal to 50 sine 35. I hope that is clear. So this force is equal to FB will be 50 sine 35 and it is in the minus j direction. Minus j direction. Okay. Since magnitude only is asked, we just need to report the length or essentially the magnitude of that vector. And please make sure when you answer the assignment questions, you need to uh, keep an eye out for questions which ask you for the magnitude of a vector and which asks you for its components. The form in which I have written, it is a component. It is a j component or y component of that vector. But if the magnitude is asked, you have to report the absolute value of that. So I hope you keep this in mind while answering the forum assignment questions. So what is the magnitude of FB? It will come to 50 sine 35, which is 28.68 newtons. And now the next question that is asked is what is the magnitude of the resultant force? We know what is the resultant force. We had a force like that, which was 50, which is at 35 degrees to the x-axis. This is the x-axis. This is 35 degrees. And then we had a drop, making the resultant come into the x-axis. So essentially, my resultant is this vector, which is easy to see that resultant is nothing but 50 cos 35 I cap. And again, we have been asked for the magnitude. So we have to repeat 50 cos 35 is 40. So magnitude of FR is, yeah, great, 40.96 Newton. Yes, so whosoever answered it, it's good that you are also solving it along. I encourage it. And in case if I make any clerical errors, you will always be able to catch them. So it's good that you also solve along so that you don't have to spend time watching this session again. It's essentially more productive if you do it side by side rather than watching it later. So I hope that that is clear. And I suppose, Mr. Ankur, I've answered your question. I suppose it is clear. Yeah, okay. Okay, okay. So you can unraise your hand so that we can take it up in the, yeah, okay. So I take it this question is done. So let me move on to a three-dimensional question. It might look involved, but essentially, if we get a hold of this question, then everything else becomes straightforward. So a pipe is fixed at A. Here we have A, where a pipe is fixed, and this is the pipe. It comes to B, and then there is a bend like that. And then on that bend, there is a rope on which a force is applied. Okay, so please take a look at the figure clearly. I'll also try to zoom in when I solve. A pipe system fixed at A is applied with a force F. This is F. This is the F vector. So F is given as 20 I cap minus 30 J cap plus 50 K cap. So if one has any problems in, or rather one is not confident about solving questions in 3D coordinate system, you please pay attention to this question and get your doubts clarified so that once and for all those are closed. It is nothing, not much much different from what we do in two-dimensional analysis. Only the cross product becomes a little more involved, which we will do threadbare so that you can understand it clearly once and for all. This is my force. And I have been given this is my x direction, this is my y direction. So can we see that x cross y comes like that? In any question, if x cross y is not, the axis which are given is not following the right-handed coordinate system, it implies that something is incorrect, at least with the convention that we are following. So if you come across a case, such a case in the assignments, you can raise it in the forum. But I doubt there will be such a case, but anyway, I'm just saying. So we have x axis like this, positive y like this, and positive z like that. So we have been given this. Okay, now let us look at let us try to understand this figure a little more. Here yeah, sorry. Yeah, it's a bent pipe. Yes, exactly. It's not a straight pipe. It's a bent pipe with a bend at B. Yeah, it is essentially an elbow. At B, it is an elbow that has been provided. And about this point, it is because it doesn't allow rotation. It says it is fixed, right? So it is fixed in space. What are the degrees of freedom it can have? It can either move, translate in about the three axes, or it can rotate about the three axes. None of which is possible in this question because they have clearly mentioned that it is fixed at that end. Okay. So yeah, so let us look at this question, this figure in more detail. Let us try to understand it better. We have a point A. We have this point A. Now to get to B, B is in the XY plane. We have to understand that this is the XY plane and B is in that XY plane only. How will we get to B from A? Essentially, we have to, in the X direction, we have to move 1.5 meters in the X direction. And then in the positive Y direction, we have to move how much? 3 meters. That is how we will get to point B from A. So if I were to write R, as we had discussed earlier, if I have to write R, B with respect to A, what will that vector be? We just saw we have to move 1.5 in the x direction, positive x direction, and 3 in positive y direction. Do we have to go out of the plane? It is in the same xy plane, so it is 0 k cap. I may as well not write it, but I'm writing here for clarity. So far, so good. Are there any questions about how we got RB with respect to A? I hope that is, yeah, okay, it is clear. All right. Now let us look at the next part. Now from B, if I have to go to C, C is clearly out of plane because this distance from the XY plane, say this is the XY plane, that is the XY plane, and from that XY plane, I'm going down by 2 meters in order to reach C. So C is definitely in three-dimensional space. It is not in the XY plane. Now let me see how I will get to C from point A. Initially, let me go to B first. I'll go to B, 1.5 in the X, 3 in the Y. Now I have to go in the X direction. I have to go 2 meters more. Let me draw that in some other color, green. I'll go like that by 2 meters from B. Then I go in the positive Y direction by 1 meter. Then I go down by another 2 meters. And then I reach C. Is it clear? So if I had that same XYZ, X, XYZ, this is our coordinate system, right? This is my coordinate system. First, I had put the coordinate system here. Let me align the axis also so that there is no confusion. Just a moment. Okay, this is becoming a mess. Just give me a minute. Okay, good enough for our purpose. That is my coordinate system XYZ. Let me make a copy of that. Now, with the understanding that this is X, this is Y, and this is Z. Please keep note of that. Initially, what I did, I put this coordinate system here at A and I wrote RB with respect to A. As we discussed, to write RB with respect to A, I must put a coordinate system at A and look at B and write the components. That we have simply done, which is this, right? So next I go to B. I put this coordinate system at B now. And then I write again RC with respect to B. So can I write RC with respect to B? RC with respect to B. What did that come out to be? I found that I have to go 2 meters in the X direction. Then I have to go 1 meter in the Y direction. Then I have to go down by 2 meters in the J direction. So minus 2 K cap. Is it clear? I take it that this is clear. So let me write it a little neatly. It was 2 I cap plus 1 J cap minus 2 K cap. So we have got these two vectors. Comfortably we have got. Now if I have to write R C with respect to A instead of B, what do I have to do? From vector addition, I know this is one vector. Then another vector is this. To get RC with respect to A, I just need to add these two vectors. And since these are expressed in its component form, it is easy for me to just add its individual components to get the actual vector. I hope this is clear. If there are any questions, please feel free to ask. It is nothing but RB with respect to A plus RC with respect to B. So what will this come out to be? Can I write it from here? Based on my knowledge of these two vectors, can I write it in component form? So it is just 1.5 plus 2, it is 3.5 I cap, 3 plus 1, which is 4 j cap, and then 0 minus 2. So it is minus 2 k cap. Is this part clear? Are there any questions? Clear, clear. Okay, that's great. I hope everyone else is also following. If there are any doubts, please do ask. All right, great. So we have got RC with respect to A. Let me take that here. And let us, so far what we have done, we saw that a pipe is fixed and it is in three-dimensional space. We wrote the force vector. We fixed two origins and wrote position vectors piecemeal and then added them together to essentially get what? We have finally got this vector. This vector is what we have got. RC with respect to A we have got. What is the position vector of point C with respect to A, with A taken as the origin? So we can see that this we have solved. Okay, this is our first part. Now using the second part says, using the cosine rule, determine angle ABC between the pipe segments BA and BC. So let me clear this a little bit. And when I'll post this file, I'll try to make it a little more neat because I'm solving it live. It could be a little more chaotic. You please bear with me. So let me just copy this and put it here. Now, what is it that they are trying to ask? We have a plane like this. We have a triangle like this, which is formed by three sides. There is one side like this, one like that, and the other like that. And all these three sides can be represented by vectors which we have already calculated, computed. Now what this triangle is in space. It is not confined to one xy plane or yz plane or xz plane. It is somewhere in space. It is an inclined triangle in space. Okay. So what we have been asked is, we know A, B and C. They are asking us to find this angle. Let us call this angle some alpha. Let me call that alpha. And we are supposed to find that. So first let me give a brief about the cosine rule. And the cosine rule and sine rule are important because we will be extensively using that in uh, parts of it in statics, and mostly it will come in dynamics for considering absolute motion and so on. So it is important that you brush up your fundamentals well. So what is the cosine rule? Let us say we have a triangle. This is a triangle. Let me call this side A, let me call this side M, N and P. Let this angle be theta. Let this angle be phi. Let this angle be some beta. Okay, so first let me start with the sine rule instead. Sine rule says that n by is is this is what the sine rule says. That is when we take n by the sine of its opposite angle is equal to m by sine of its opposite angle is equal to p by the opposite of its the sine of its opposite angle. This always holds in a triangle, and this is what is the sine rule. So suppose you come across a situation where you know two angles on one side, you can easily find out the rest of the quantities by using this relation. That is what this is helpful in. Let us look at what the cosine rule is. So if I, let us say, in the same, I won't be writing all the three combinations for the cosine rule. You can just extrapolate from here. Let us say that I don't know this angle and I don't know this angle either. I just know two sides. I know two sides, P and M. I know their lengths and I know this theta. Then I can find out the third side. Let me call this side as S. Say it is S. So the cosine rule says that S squared is nothing but P squared plus M squared minus 2PM cos theta. This theta. This is what the cosine rule says. Essentially, it is a variation of our vector addition. That is all. Our triangular law of vector addition. It is just a variation of that where one angle is negative. That is all. So I hope that this is clear. Please keep these in mind and practice a couple of questions so that the learning gets reinforced, and then you are able to apply them easily as and when you are required to. Okay, so far so good. Now let us get back to our question at hand. What have we been asked? We have been asked to calculate this angle and we called it alpha. So using cosine rule, we can say, using the cosine rule, can we say that AC squared is AB squared plus BC squared minus 2AB BC cos alpha? We can say this. This is what we have seen in that cosine rule. Now what is AC? It is nothing but magnitude of RC with respect to A. That is what it essentially is. Similarly, AB is magnitude of RB with respect to A. And all these vectors we have already calculated. BC, let me write BC is RB RC with respect to B, its magnitude. Right. So let me add one more page here. Let me take these here. So this is clear how this has come about. We have discussed this in detail. Now rest is just a matter of mathematical calculation. So let me take my vectors from here. I'll copy and put it. And let me also take this vector here. RC with respect to A is this vector we have. RB with respect to A is this we have. And R, it is this. Okay, let me delete these boxes. I hope this is clear. It's a little clumsier. I'll tidy it up and upload, but for now, you please bear with me. Now, can we calculate AC? Can we calculate the magnitude? There is no problem. We can. What is the magnitude of the first vector? Root over 3.5 squared plus 4 squared plus minus 2 squared. It will come to 5.6789 or whatever that is. Essentially, this will be in newtons because this is a force. Oh, no, this is a position vector. Okay, fine. This won't be in newton. This will be in meter only. Pardon my mistake there. I thought it was a force. So AB, similarly, it will be root over 1.5 squared plus 3 squared plus 0 squared 3.354 meters. BC I can calculate as 2 squared plus 1 squared plus minus 2 the whole square. I'm writing this specifically so that because sometimes there is a mental block about adding or subtracting, I'm writing this threadbare so that there are no remnant doubts. So this is 3 meters. Okay, so let me add one more page. Now we have the lengths of these 3 and I know this expression. Next is simple substitution. AC is, now that we have calculated AC, AB and BC, we know this formula. We know this formula. So the next part involves simple substitution. So we know AC squared is AB squared plus BC squared minus 2 ACAB cos alpha. We know what is AC, AB and BC individually. So we'll just substitute that. So it comes out 32.25 is 11.25 plus 9 minus 2 into 3.354 into 9 into cos alpha. So from here we can calculate cos alpha as minus 0.5693. So alpha comes out to be cos inverse of minus 0.5963, which comes out to be 126.61 degrees. So if we look at the options for this question, we're able to see that 126.65 is an option over there. So this is the correct answer to this. So I hope that that is clear. The issue while solving in the live class was that these terms, we had substituted these as AB square and BC squared instead of AB and BC. So that is why the numbers were not adding up, which has since been corrected. So there was nothing otherwise wrong with the calculations, just that while substituting, we can see that this is AB squared. So here we should be substituting AB instead of AB squared, which was what was happening uh, in the live class. So that has since been corrected. So I hope that that is clear. My main motive was to show how position vectors are calculated and how you write them, how you add them, and how you operate upon them. So in that respect, if there are any questions, you please ask now. Is the explanation clear? Yes. What is not clear, sir? Please ask. Yeah, Mr. Nishant, what you have something is not clear, you please ask. Clear, sir, no question. Acha, okay. Oh, that is what you meant by no. All right, fine. I thought you didn't. Okay, so I hope that I have done some justice to explaining this. So let us move to the. So if we move on to the next question, what it says is 87. Okay. Anyway, when I will be posting this, I'll post it with the correct solution because there are some numbers that are not adding up. We'll see why that is. Moving on to the next question, which is not essentially dependent on that because we have a force here that is given in the question. So let me bring that force here and put it here. We have this as the force, and then we have been asked to calculate what is the magnitude of moment in Newton meter of the force F about point A. So how will we calculate that? Do we have the recipe for that? Moment about A. The moment vector about A is, where is the force applied? Force is applied at C. From the figure we know it is applied at C. So we essentially write C with respect to A crossed with this F. That is all that needs to be done. So do we have RC with respect to A? Yes, we have calculated that. We have it here. RC with respect to A. And here there is essentially no mistake because let us look at the figure. Should the answer be in degree or radian? No, the answers, the question will essentially mention it. So in this question, if you see, all the answers are already given in degree symbol. So it will be in degrees. If specifically you have to report it in radian, it will be told. All the units will be mentioned in the question. So to that end, we have tied it up. RC with respect to A. How quickly can we see this? From A, we have to walk 3.5 in the plus x direction. Then we have to go 1. Okay. I think this is where the problem is. No, okay. This is 4 in the y direction and then minus 2 in the z direction. This is the component form of RC with respect to A. So what is RC with respect to A? Quickly we can see it is 3.5i plus 4j minus 2k. Is that what we got here? 3.5i plus 4j minus 2k. Exactly, this is what we have got. So there is no problem in this. At least this vector. Okay, so let me put that here. This is over here. This is over here. Now, do we know how to calculate cross products? It is simple. The moment vector is, you might remember that mnemonic of determinant. So essentially that is what we are supposed to do. We'll place the three components here. Which is the first part that comes? R. So we have to populate R in the second row, not F. So R is 3.5i plus 4j minus 2k. Second component is force. That is what we will populate. So it is 20i minus 30j plus 50k Newton. So if we calculate this, this will give us the moment that is being applied. So can we do that quickly? I into 4 into 50 minus 2 into 30 plus j would be minus 2 into 20 minus 3.5 into 50 plus k. Essentially, what I suppose you all are familiar with this. For I, I'm eliminating these two rows and taking the cross multiplication of the others and subtracting. It is basic. Yeah, okay. I suppose you know that. K is minus 30 into 3.5 minus 4 into 20. So this will come out to be 140i minus 215j 185k. Sorry, minus 185k. So I hope that this is correct and without any errors. You can just cross check in case you're solving it by the side. Okay, so we have got the moment here. Moment is correct. It's correct. Okay, fine. Thank you. Moment about A. It has come to 140 I cap minus 215 J cap minus 185 K cap. So let us look at the question. They have asked for magnitude. Do we have do we know how to calculate the magnitude? It is simple. Magnitude of this moment is nothing but root over 140 squared plus minus 215 squared plus minus 185 squared. Anyone? What this comes to? Okay. This comes to 316.31 essentially Newton meter. So this is what we are getting as magnitude of A. So let us look at the answers. Yeah, so we have it here. So option D is correct. So I hope this question is clear. Essentially, this is how we calculate cross products. But in 2D, we will be seeing that this component won't be there. So what will happen is we end up multiplying only these two. That is what essentially happens. Mistake in equation. Yes, please. What is the mistake, sir? Yeah, please go ahead. नहीं देखिए वो क्या है हाँ ठीक है मैं समझा देता हूँ ये भी आप ठीक ही बोल रहे हैं हमें जैसे सिखाया गया है ना जैसे हम आई कैप जब हम करते हैं तो हमारा ऐसे होता है ये मल्टीप्लाई माइनस ये है ना उसके बाद अब हम जे में जाते हैं तो हम पहले माइनस लगा के फिर हम ये करते हैं इन दोनों को मल्टीप्लाई करते हैं ठीक बोल रहा हूँ ना आप भी ऐसे ही करते होंगे जैसे ही आप जे पे जाते हैं तो आप पहले 3.5 इंटू 50 करते हैं ना तो मैंने बस ऑर्डर बदला और कुछ नहीं किया है तो मैं जब प्लस क्योंकि तभी हम माइनस जे लिखते हैं यहाँ पे अगर हम यहाँ पे माइनस जे ना लिखे प्लस जे लिखें तो हमको एसेंशियली ये पहले करना चाहिए और ये बाद में बस वही फर्क है और कुछ फर्क नहीं है आप ठीक बोल रहे हैं आप अपने मेथड से ही करिए अगर आपको कंफर्टेबल लग रहा है तो आप उस मेथड से करिए आंसर वही आएगा क्योंकि आप जैसे बता रहे हैं ना कि यहाँ पे ये नेगेटिव होना चाहिए तो मैंने उस माइनस को अंदर मल्टीप्लाई कर दिया बस मैंने यही किया है और कुछ नहीं किया ठीक है क्लियर है हाँ ओके ओके so because the mnemonic that we remember is generally we multiply this way and then that and then same way we go about doing for j and k also so that was what the he was doing so that is absolutely fine I just did not include that minus. I went by plus and did it cyclically. That is all the difference is. Both the answers will be same. There is absolutely no difference in the methodology. Essentially, I've just multiplied the negative sign, taken negative sign into the bracket. So other than that, are there any questions? I hope at least if you have understood this problem correctly, what this problem essentially uh, is trying to address is first how to write vectors in 3D in component form. Essentially, when we have to write position vectors, we fix the origin. We saw that clearly. We fix the origin. We walk to the other point and write the components quickly. Then when we do it piecemeal, we want the final vector, we just add them component wise. So that becomes very simple. Secondly, we have to, while calculating the angle, this problem helped us understand how to apply sine rule and cosine rule. But I suppose that the sine rule and cosine rule application part is clear. That is how we are supposed to apply that. Third part is the moment, how we calculate cross products for 3D vectors. Why I emphasized on having 3D vectors in the very first session is because once we get this out of the way, then going back to 2D becomes very easy. It is just essentially one component. Because when we look at a plane, which is in the XY coordinate system, let us say, and we want to calculate moments in this plane, essentially everything will be about Z. So we will multiply these. We needn't go for this determinant form. But this determinant form will come in handy when we go to 3D kinematics, which will be the very last session in dynamics. But nonetheless, I wanted to get this out of the way because generally 3D analysis gives makes people a little clouded. They think that it is quite difficult or they have some inhibitions about it. So my motive was to remove those inhibitions and show that it is much like 2D analysis, just the addition of one more coordinate to the problem. So to that end, I hope this problem has been meaningful and helpful. So if there are any questions that you have, I'll be happy to take them now. And one more thing I would request from you all, if there is any feedback about my presentation and if the way I'm speaking or I'm explaining is not clear, I would request you, as some of the people had raised that I had asked that I speak in Hindi. So if there are issues like that, or if I'm going very fast, or if I'm not articulating things properly, I would request you to please raise it so that both we together we can take this session to its logical conclusion, which has to be beneficial for the people who are attending it. So to serve that purpose, I suppose I would request you to please record your feedback if you have any. Okay. So this course is called Statics or Dynamics. This course first 6 weeks will deal with statics. Second 6 weeks or the last 6 weeks, so to speak, will deal with dynamics. So week one is running. Then we'll go to equilibrium, look at trusses, then beams, then virtual work and energy principles. Then we'll deal with a little bit with friction. Then we'll step into dynamics with a bit of belt friction. Then absolute motion, relative motion, rotating frame of reference for velocity, rotating frame of reference analysis for accelerations. Then we will have kinetics, 2D kinetics, and we'll finish with 3D kinematics. Any other questions about my mechanics syllabus? What syllabus is that, sir? Mr. Akhilesh? अच्छा आप अच्छा आप एक बात बताइए, आपने ये स्वयं पोर्टल पे इस कोर्स पे वो किया हुआ है ना एनरोल? हाँ, तो आप एक काम करिए, आप जो भी आपके पास सिलेबस है उसको आप उस फोरम में भेज के पूछ लीजिएगा, हम फोरम में उसका आंसर दे देंगे। ताकि आपको ही नहीं, जो ये सेशन अटेंड नहीं कर रहे हैं और जिन्होंने फोरम ज्वाइन किया हुआ है उनको भी बेनिफिट हो जाए, है ना? अच्छा, नहीं देखिए, इस कोर्स में तो हम मोर और लेस मीडियम ही फॉलो करेंगे, बट आप अगर मीडियम से काफी, इफ यू आर फेमिलियर इनफ विथ प्रॉब्लम्स ऑफ मीडियम, आई डोंट सपोज अनदर बुक इज गोइंग टू डू एनी गुड, एनी मोर गुड। अगर आपके कॉन्सेप्ट क्लियर है और आपने मीडियम कॉन्फिडेंटली सॉल्व कर दिया है तो मेरे हिसाब से वो सफिशिएंट रहेगा। उसके अलावा आप किसी एग्जाम के लिए अपीयर कर रहे हैं तो आप उसके प्रीवियस ईयर क्वेश्चन उठा के देख लीजिएगा। कोई इश्यूज हैं, कोई क्वेश्चन आपसे कुछ डाउट है, तो आप हमारे फोरम में रेज करिए। क्वेश्चन मत भेजिएगा सीधा कि ये सॉल्व करके दे दो, क्योंकि वो तो हम नहीं कर पाएंगे। आप अगर, आपके पास कोई क्वेश्चन है और अगर आपने उस पर अटेम्प्ट लिया है, आप अपने हैंड रिटन सोल्यूशन हमें भेजते हैं, तो हम डेफिनेटली उसमें, आपको कोई गलतियां हो तो हम, वी विल डेफिनेटली आंसर। It just won't be that if, let me make it clear for others also, that you are welcome to ask your questions in the forum, provided you have made the attempt first. It shouldn't be that you post a photograph of a question in the forum and then you asked us to solve it. That will not be happening. Let me make that very clear. Nor will that be entertained in this live session. But if you have made the attempt on the question first, and if you send us your handwritten solution and then you are stuck somewhere, we'll be more than happy to help you out on anything. So I hope that to that end, I have made it clear. Any other questions or comments about this session, or what is it that you expect? Did you find it helpful in any way? Okay, okay, thank you. I see. Oh, I see. Okay, thank you very much. Okay, I hope to keep up the same spirit in the upcoming sessions also. सर, असाइनमेंट कैसे जमा होगा? ऑनलाइन होगा। जैसे आप असाइनमेंट में जाएंगे तो मोस्टली एमसीक्यू है, कहीं कहीं पे आपको वो देना है, न्यूमेरिकल नंबर एंटर करना होगा। जैसे हमने ये कैलकुलेट किया 316, है ना? तो इस क्वेश्चन में तो ऑप्शन में दिया होता है, किसी किसी में बस ये ऊपर वाला दिया होगा कि व्हाट इज द मैग्नीट्यूड, और एक स्पेस होगा जहां पे आपको नंबर एंटर करके सबमिट करना है। तो वो जैसे ही उसमें आपके असाइनमेंट में टॉप राइट पे उसका डेडलाइन लिखा होगा, जैसे ही डेडलाइन खत्म होगा तो आपको अपने मार्क्स मिल जाएंगे। हाँ जी। नहीं देखिए, असाइनमेंट एक तरफ है और एग्जाम एक तरफ है। ठीक है, असाइनमेंट में हमारा फोकस ये है कि आप फेमिलियराइज हो पूरे सब्जेक्ट पे, तो वहां पे हम छोटे कैलकुलेशन से उतना आप कॉन्फिडेंट फील नहीं कर पाएंगे। इस वजह से असाइनमेंट विल इनवेरिएबली बी लेंदी। बट एग्जाम में एग्जाम के हिसाब से ही आपको क्वेश्चन पूछा जाएगा। और अगर आपको ऐसा लग रहा है कि एग्जाम में कोई ऐसा क्वेश्चन पूछ दिया जिसमें बहुत ज्यादा कैलकुलेशन लग रहा है, तो शायद आप कोई एक क्लू नहीं पकड़ पाए हैं एग्जाम के क्वेश्चन में जो आपको शॉर्टन कर सकता था। तो पर्पस ऑफ दैट क्वेश्चन इज दैट यू शुड आइडेंटिफाई दैट क्लू। Okay, it will be a problem which is comfortably solvable in that exam duration. But assignments, it is a different thing. Assignment is for your learning, because it is 2 weeks or 1.5 weeks or something are given for the assignment. They will definitely involve questions where you have to do lengthy calculations, but that is for your own good and confidence. Okay, yeah, all right. और कुछ, any other question? I have tried to answer and conduct some of the part in Hindi also. I suppose that has been accepted and it was beneficial for some of you. So if there are any other, sir, आपका सेशन वेरी गुड बट लैंग्वेज प्रॉब्लम। अच्छा, तो मैंने हिंदी में भी समझाने की कोशिश तो की थी। अगर आपको, अगर ये परसिस्ट कर रहा है तो आप, मतलब आप जैसे बीच में टोक के आप बोल दीजिए कि हिंदी में भी समझा दो, तो मैं समझा दूंगा, है ना? या ओके, ओके। क्योंकि अब काफी सारे लोग हैं तो एक कॉमन पहले इंग्लिश में आई विल ट्राई टू एड्रेस इट। उसके बाद किसी को समझ में नहीं आ रहा है, क्योंकि लैंग्वेज शुड नेवर बी द इश्यू फॉर अंडरस्टैंडिंग कॉन्सेप्चुअली। द आइडिया इज कि आप कॉन्सेप्ट समझें यहाँ पे। अगर वो आपको लैंग्वेज की वजह से समझ में नहीं आ रहा है तो आप प्लीज मेरे को टोक दीजिए बीच में, मैं आपको हिंदी में भी समझा दूंगा, इंग्लिश में समझाने के बाद, जो कि शायद मैंने किया भी। या ओके, इट्स गुड टू अंडरस्टैंड इन बोथ द लैंग्वेज। ओके, एंड फर्दर मोर आई एम कन्वर्सेंट इन तमिल ऑल्सो, so in case somebody feels the need to ask me to explain it in Tamil, I'll try my best to do so as well. Okay, so to recap, what we have seen today is how forces are calculated, how moments are calculated, what is law of vector addition, what is a fixed vector, what is a free vector, what is a sliding vector that we have seen in detail. Then we saw how to write forces in its component form. We have understood the very important, we can't get in Tamil. ओके, नहीं आपको तमिल में समझ में नहीं आएगा, बट और किसी को जरूरत पड़ रही है तो मैं बोल रहा हूँ। जैसे आपको हिंदी में समझ में आ रहा है तो मैं हिंदी में समझा दूंगा। आप ही के जैसे अगर कोई और हैं जिनको तमिल में समझ में नहीं आ समझना चाह रहे हैं तो आई कैन डू दैट एज वेल, was what I was trying to say. Then we have covered this important principle of transmissibility, which is very essential to understand force systems. Then we saw how to calculate resultants of forces, how to respect constraints that are given in a question, and to arrive at answers. This 3D question, I suppose it would have helped in removing inhibitions, जो भी जैसे थोड़ा डर बैठ जाता है कि 3D में आ गया है तो कैसे आंसर करना है। मेरी उम्मीद यही है कि इस क्वेश्चन को जिस तरीके से हमने सॉल्व किया है उसके बाद आपको 3D फोर्स सिस्टम्स को डील करने में कोई तकलीफ नहीं होगी, क्योंकि एवरीथिंग वी हैव सीन। यहाँ पे जैसे हमने ओरिजिन लगाया तो हम कैसे दूसरा वेक्टर लिखते हैं, पोजीशन वेक्टर कैसे लिखते हैं, क्रॉस प्रोडक्ट कैसे लेते हैं, साइन रूल क्या है, कोसाइन रूल क्या है, एंड हाउ डू वी कैलकुलेट मोमेंट्स, क्रॉस प्रोडक्ट्स ऑफ three dimensional vectors, how we do. So that we have successfully seen in this session. To repeat it, I will be uploading this the file where I'm writing along with the recording of this session, preferably tomorrow, and it will be made available to you as per the schedule decided by the Swayam team. Sooner or later it will be made available within a week's time, I suppose. और इसको आप कहाँ पे देख सकते हैं, जैसे आप स्वयं पोर्टल पे जाते हैं जहाँ पे वीक 1 वीक 2 होता है, वहाँ पे नीचे लाइव सेशंस एक लिंक होगा, वहाँ पे जाएंगे तो आपको वीक वाइज आपको यूट्यूब पे वो हमारा अभी जो चल रहा है वो रिकॉर्डिंग मिल जाएगा और ये पीडीएफ फाइल भी मिल जाएगा। एंड व्हेन आई पोस्ट दिस पीडीएफ फाइल आई विल मेक श्योर दैट द कैलकुलेशंस आर करेक्ट. And I repeat, if you are actually solving it along with me, it will be beneficial for you as well as helpful for me in case I make any, because I'm also solving it live. I'm not looking at some place and I'm writing, I'm solving it live. So there is always a possibility of having some, plus minus errors. So it would be good and helpful if you also solve it along with me. Other than that, I think I have nothing more to say as of now. We'll meet again for a discussion on questions from week 2 next Friday 6 to 8 p.m. Same link, same Google Meet link पूरे 12 हफ्ते के लिए चलेगा, है ना? Okay, so yeah, that is all I have to say. So if there are no further questions, I'd like to call it a day. If there are any further questions, you please raise them now. I hope this session was helpful. Yeah, thank you. Thanks a lot. Okay. Okay, so I suppose we can wrap up the session now. So I'll see you guys next week. In the meantime, forum मत भूलिएगा, आप अपना questions आप forum में raise कर सकते हैं, है ना? Forum join भी कर लीजिएगा ताकि आपको भी update आता रहे. Okay. आप उसमें जाएंगे ना, जैसे स्टार्टिंग ऑफ द लेक्चर में मैंने स्टार्टिंग ऑफ द सेशन में दिखाया था, आप स्वयं पे जाएंगे तो ऊपर आस्क का क्वेश्चन एक बटन होगा, आप उस पर क्लिक करेंगे तो वो एक गूगल ग्रुप्स पे आपको लेके जाएगा जहाँ पे ज्वाइन ग्रुप एक ऑप्शन होगा, आप ज्वाइन ग्रुप कर लीजिए तो आपको भी अपडेट आता रहेगा। जरूरी नहीं है कि आप ही क्वेश्चन पूछे, किसी और ने क्वेश्चन पूछा है, हमने उनको जवाब दिया तो वो वाला जवाब भी आपके पास आ जाएगा ताकि यू कैन रेफर टू दैट ऑल्सो, इट्स एन एडिशनल बेनिफिट। ओके Okay, so thank you guys for attending. I'll see you in the next session. Bye. Bye.